Hello and welcome to the Screencast where we will find exact values of the sine and cosine functions. We will quickly review the definition of the sine and cosine functions. Then we'll find exact values of these functions at angles explicitly defined on the unit circle. Lastly, we'll look at some cases where at first glance the angles given are not obviously on the unit circle. Previously, we defined the sine function to be the y-coordinates as a function of an angle on the unit circle, and we defined the cosine function to be the x-coordinate as a function of an angle on the unit circle. It is important to emphasize that for both of these functions, the inputs are angles, and then either y or x coordinates are outputs. Let's look at our first example of evaluating these functions. The first thing we're asked to evaluate is the sine of pi over 6. We know pi over 6 is the input and represents an angle. We know that the sine value will be the y-coordinate at the angle pi over 6, which is 1/2. So the sine of pi over 6 equals 1/2. Next, let's evaluate the cosine of 2 pi over 3. We know 2 pi over 3 is the input and represents an angle. We know the cosine value will be the x-coordinate at the angle 2 pi over 3, which is negative 1/2. So the cosine of 2 pi over 3 equals negative 1/2. The next two problems are to evaluate the sine of negative pi over 6 and cosine of negative 2 pi over 3. Notice that here we have negative angles. We need to remember that when we defined the sine and the cosine functions, we said that we were going to travel counterclockwise around the unit circle, starting on the positive x-axis. So if we have a negative angle, all that means is that we're going to travel clockwise around the unit circle, starting on the positive x-axis. So if we want to find the sine of negative pi over 6, we're going to traverse the same distance along the circle as we did for pi over 6, but we're going to travel clockwise instead of counterclockwise. Notice pi over 6 had an arc length that got us to this point. So negative pi over 6 is going to have the same arc length, but in the opposite direction. We see that traversing the circle, pi over 6 in the clockwise direction is equivalent to traversing the circle 11 pi over 6 in the counterclockwise direction. That means we can say that the sine of negative pi over 6 is equal to the sine of 11 pi over 6. Regardless of how we think about getting to this point, we see that the y-coordinate is negative 1/2. Therefore, the sine of negative pi over 6 is equal to negative 1/2. All right, now let's evaluate the cosine of negative 2 pi over 3. We know negative 2 pi over 3 is the input and represents an angle, and we also know that because the angle is negative, we need to imagine traversing the circle in the clockwise direction. We're going to traverse the circle the same distance as we would for an angle of positive 2 pi over 3, just in the opposite direction. Notice the length of the arc to get to 2 pi over 3. We're going to traverse the circle the same arc length, but in the clockwise direction. That gets us to 4 pi over 3. That means we can say that traversing the circle 2 pi over 3 in the clockwise direction is equivalent to traversing the circle 4 pi over 3 in the counterclockwise direction. And that means we can say that the cosine of negative 2 pi over 3 equals the cosine of 4 pi over 3. Again, regardless of how we think about getting to this point, we see that the x-coordinate is negative 1/2. Therefore, the cosine of negative 2 pi over 3 equals negative 1/2. The next thing we want to do is think about how to evaluate a function at an angle that is larger than 2 pi. For example, if we want to find the cosine of 13 pi over 4, we have to keep in mind that a full rotation around the circle is 2 pi, and because 13 divided by 4 is 3 1/4, we know that 13 pi over 4 is greater than 2 pi. So one way we can evaluate this is to think about the fact that anytime we add or subtract 2 pi from an angle, that has the same effect as adding or subtracting one full rotation around the circle. So if we want to find the cosine of 13 pi over 4, we're going to continue subtracting a full rotation 2 pi until we find an angle that hopefully is on the unit circle. Since we have a fraction with a denominator of 4, we're going to think of subtracting 2 pi as subtracting the equivalent fraction 8 pi over 4. So if we want to find the cosine of 13 pi over 4, that will be equivalent to the cosine of 5 pi over 4. We see that the angle of 5 pi over 4 is in the third quadrant, and the cosine of 5 pi over 4 equals negative square root 2 over 2. Therefore, we can say that the cosine of 13 pi over 4 also equals negative square root 2 over 2. All right, the last thing we want to do is find 4 different angles of t for which the sine of t equals negative square root 3 over 2. Notice that t is the input, and since the input of the sine function is an angle, we're looking for 4 angles where the sine function equals negative square root 3 over 2. Sine is defined to be the y values, and looking on the unit circle, we see that the y coordinate equals negative square root 3 over 2 at the angles 4 pi over 3 and 5 pi over 3. So we found 2 angles, or values for t, where the sine of t equals negative square root 3 over 2. We were asked to find 4 values for t, so we're going to use the idea that a full rotation, or 1 period, equals 2 pi. We can find 2 more angles by either adding or subtracting 2 pi to the angles we found. Here, the common denominator is going to be 3, so we're going to think of 2 pi as 6 pi over 3. If we add 2 pi, or 6 pi over 3, to 4 pi over 3, we get 10 pi over 3. Or alternatively, if we subtract 6 pi over 3 from 5 pi over 3, we get negative pi over 3. So this is a nice example because we can quickly see that traversing negative pi over 3 is equivalent to traversing 5 pi over 3. There's really infinitely many angles that you could find by repeatedly adding or subtracting 2 pi from the original 2 angles we found. I hope this video helped you think about how to evaluate the sine and cosine functions at different angles, especially angles that at first glance don't seem to be on the unit circle.